Hello everyone. In the last session we have seen physical design of IoT. Today we are going to look at logical design of IoT. So logical design of IoT includes three things. One is IoT functional blocks, IoT communication models, and last one is IoT communication APIs. So first let's look at IoT functional blocks. So when you look at an IoT system as a whole, so what are the different functional blocks or functional components we will be looking at? So these are the 6 functional blocks. So we have device, communication, services, application, security, and management. So first let's look at device block. So as I already told you in the previous session, devices means either it can be sensors, actuators, or any computing device or any kind of other IoT devices. So these devices include sensing, actuation, monitoring, and control functions. And after that we have communication block, so which is the main thing in IoT, Internet of Things. So without communication there is no use of IoT. So whatever data is gathered by the IoT devices, or in particular the sensors, the data should be sent to either cloud or some other server which is in the internet. Okay, so communication plays a significant role in the success of Internet of Things. And then we have services block. So these services can be device identification services, device discovery services, or it can be authentication service, sort of those things. Okay, you can treat services as middleware. Okay, and then we have application block. So this is where the users of the application interact with IoT system. So we have either mobile applications, desktop applications, the user interfaces, and you can view the data which is collected by the sensors and the devices. So you can play with the data, you can make analysis, and you can control other aspects of the IoT system through the application. Okay, and we have management block, which allows us to manage the other components in the IoT system, other functional blocks, and then finally we have security block. So without security, IoT is sort of useless. Okay, so whatever you are going to develop or use, it should have security. So some of the security services, or you can say properties, are confidentiality, integrity, availability, and authentication. So I am not going into detail what are these things. Maybe I will touch these things in the future sessions. Okay, so these are the different functional blocks. And next thing is communication models. Just now I told you that communication is very important for the success of IoT. So what are the different communication models available are 4. We have request response model, publish subscribe model, push pull model, and last one is exclusive pair model. So let's see about each one of these things in detail. So this is the request response model, or you can say client server model. So in this model, we have two main entities. One is client, another one is server. Okay. So client can be typically a mobile application, desktop application, or whatever. So client will be maybe a browser. Let's say just you are browsing web pages. That means you are sending different requests to a server. So let's say you are opening facebook.com, that is a request from your browser. It goes to the Facebook server. The server processes your request and gives back some response. That is request response model. So we have a client which sends requests, and we have a server which takes the request or receives the request, processes the request, and then sends back the response. And in turn, the server might access other resources. For example, it can be a database, or it can be some kind of files, data stored in the files, or it can be images. Okay, so these resources can be anything, maybe audio files, video files, or whatever. Okay, and another thing is this request response model is stateless. That means when the client is sending requests to the server, so the server will not know about the client if the client has already sent the request previously or not. Okay, that is not available in request response model. So each request is a new connection, and the server treats uh, them as separate clients. Even though all the requests are coming from the same client, it will treat them as separate. So that is the meaning of stateless. So that is about request response model. And next one is publish subscribe model. So here we have three main entities: publisher, just like a client, uh, broker, like a server, and we have consumers. So the three main entities are publisher, broker, and consumer. Okay, and this publish subscribe model is widely used in IoT. Okay, I am not saying other models will not be used, but this is the mostly used communication model, publish subscribe model. So let's say we have a smartphone. Okay, and what is a smartphone means everything is connected to IoT. For example, the house contains smart AC, smart lighting, smart surveillance, smart fridge, smart washing machine. Everything is smart. Smart means connected to internet. Okay, and all these sensors will be gathering data, and they will be publishing the data. So here you can treat sensors as publishers. Okay, to where they will publish is they will publish to topics which are maintained by broker. It is like a server. Okay, so there is an entity called broker which will maintain different topics. Okay, so let's say this topic is AC. Okay, let's say the sensors from the smart AC are sending the data to this topic which is AC. Topic 1 is AC, and let's say this is smart lightning. Okay, so the light sensors are sending data to topic 2 which is smart lightning. Okay, and consumers, let's say this is you, and consumer 2 is your dad, and consumer 3 is your mom. Okay, and you and your dad have subscribed to this AC data, smart AC data. So both of you can see that data from data related to smart AC, and your mom can see data related to smart lighting. Okay, so this is how publish subscribe model works. So the data is published by publishers, uh, and it is published into topics which are maintained by broker, and these topics can be subscribed by uh, consumers. Okay, right. And then we have push pull model. So again, here we have three entities. Just like in the previous model, we have publishers and we have consumers. And instead of broker, now we have something called queues. So a queue is a data structure which follows first in first out mechanism. So whatever data enters first into the queue, that is the first thing to leave out. Okay. So for example, let's say there is a pulse sensor and it is a publisher. Let's assume that there is a pulse sensor which is a publisher. It is sending data into these queues. So it is monitoring the heartbeats, 68, 70, 64, 66, 61, 63. So here, whenever the consumer is subscribing to this data, the data will be consumed in a sequence. Yes. So the first data which got into the queue is 68. After that, next data will data will be 70, like that, so on. Okay. So there is some kind of sequence in which the data is consumed in this push-pull model. So this is the only difference between publish subscribe and push-pull model. And last model is exclusive pair model. So again, here we have two entities, client and server. So this is very similar to request response model, but the only difference here is it is exclusive pair model is stateful, whereas request response model was stateless. So here what is stateful means the server can keep track of different requests coming from the same client. So how is this possible is whenever the requests are sent, before the server accepts the request, there is something called connection setup. Okay. So client will send request to set up connection, and it will send, the server will say okay. Okay, it will acknowledge the connection setup. So connection is established at this point, and then the client will send data and server will respond back. And this can happen multiple times. And finally, after the task is completed, the connection will be closed. Okay, client will say I want to connection the close, and server will respond back with okay, you can close. Okay, all right. So these are the four communication models, and next we are moving into communication APIs. So API means application programming interface. Okay, application programming interface. So it is like I will explain this. There will be a server, and you will have code running on the server. So there is code block 1, code block 2, code block 3, etc. So there are a bunch of functionalities, and these functionalities will be accessible through API. Okay, consider YouTube. YouTube has its own API, right? Okay, and let's say one functionality can be searching for YouTube videos. Another functionality can be uploading videos. Okay, another functionality can be deleting videos. Like that, you can do a lot of things using YouTube API. Another functionality can be maintaining playlists. playlists in YouTube. That can be another functionality. So all these things are available through YouTube API. Okay, so they are stored in a server, and we have internet. Okay, and you are a developer. So this is you. You are a developer who creates software, and you can use that YouTube API. Okay, to create your own application. Okay, so that is how APIs are useful. Okay, so you will be accessing the API, and API in turn will be accessing the code which is deployed on the server. And these things can be interacting with other resources like database. Okay, so that is how API is useful. And we have two API communication models. One is REST, another one is WebSocket. Okay, first we will look at REST. Okay, REST means representational state transfer. Okay, we'll come back to this. Uh, so to give you an example, I think all of you are familiar with weather applications on your mobile, right? So one famous weather forecasting website or application is AccuWeather. Okay, and whenever you are searching for weather in a particular location, the request will go like this to the server. Okay, so let's say I am searching for weather in a location called Bhimavaram. Okay, and this request will be going to the AccuWeather server from your mobile phone. So AccuWeather's API will catch this request, and it will extract this information, search it for in the database, and then send back you the response, which will look like this. Okay, it doesn't send back image, it will send the data, and the data is represented on your mobile phone like this. Okay, so you can see here, this is you in your mobile accessing AccuWeather, and you had selected, let's say, Hyderabad, Bhimavaram, or whatever location, and you hit submit. The request will go, either it will be a get request or post request. Most probably it will be a post request, and the API, AccuWeather's API will catch the request, I mean accept the request. It will search for the weather in the database, weather details, and the database will send back the data, and then that will be sent back to your device, either mobile or laptop or desktop. So generally the response from the API or the server running the API will be either in XML format or JSON format generally. Okay, right. So another example, uh, so as I told you, there will be a clients who will be sending requests, and most of the time the request will be HTTP requests or HTTPS requests. Okay, and these are all request types: get request, post request, put request, delete request. They are request types. If you want to know about them, you can search on internet. So these requests will be sent to the REST API, which is running on a server, and based on the request, it will access the database, fetch the response back, and send the response back to clients. Okay, and as I told you, the response will be generally in JSON format or XML format. JSON means JavaScript object notation, and XML means extensible markup language. Okay, okay, let's see some points. So whatever we are talking, it is REST API. REST means representational state transfer. So it is a set of architectural principles which developers use to design web services and web APIs, web application programming interface. Okay, and as I already told you, REST API follows request response model, right? And there are some principles associated with REST, and they are applicable to components, connectors, and data elements which are in the system. Okay, and these are the principles or constraints. Client server. So as it is based on the request response model, there are two main entities. Client will be sending request, server will accept the request and send back response. As it is request response model, it is stateless. So the server will treat each request as individual requests, and the response can be catchable. So catchable means the response will be stored temporarily on the client device for some time. Okay, so there will be expiry for this cached content. After the time expires, the content is automatically deleted from the client devices. Okay, so why the content is cached means for fast performance gain. Okay, it will be, the response will be faster, and it is layered system. So it provides uniform interface, and I mean the REST API provides uniform interface to access the server, okay, or the end service or whatever, and it runs code on demand. So whatever the end user is accessing, I mean the type of service, the code related to that service will be executed. So that is the meaning of code on demand. Okay, right. So REST uses HTTP request. HTTP means Hypertext Transfer Protocol. It's a application layer protocol, and the services are represented using URIs, Uniform Resource Identifiers. Okay, and there are different HTTP methods, like I already told you: get, post, put, delete. So again, the client sends requests, either any one of these things. The server will receive those requests. It will access resources like database and files, sends back the response, and again the server sends the response to client either in JSON or XML format. And the second communication API communication model is Websocket-based. Okay, so this allows full duplex communication. So client and server can communicate simultaneously, send the data and receive the data simultaneously. So it follows exclusive pair model, which I discussed few minutes back. And since it is exclusive pair model, it is stateful. So there is no need of establishing connection for each request. So once a connection is established, all the requests go through that connection only. No need to establish a separate connection with each request. So this is suitable for IoT application which needs low latency. Okay, since since less data is transferred between uh, client and server. Okay, so there is low latency delay. Okay, so this is how WebSocket-based communication looks like. So first connection is established, data is transmitted, and finally the connection is closed. Okay, right. So that's it for this session. If you have any questions, you can type in the comments below the video. Thank you.